All right, let's go welcome our next speakers, Brian and Cody, for the control room. What's up, guys?
Hello.
Control room.
He's Brian. I'm Cody.
Cody, Brian. Okay.
So why is a component important? It drives the various operations of the processor. The control ROM is ultimately what turns the instructions into things the processor can actually do stuff with. It controls which components are enabled and disabled based on the instruction. Its output lines go to muxes or memories, and based on whether it's 1 or 0, that component is on or off, and it directs the data flow through the processor and the general operation based on the instruction. And so the instruction comes from the instruction memory, goes through the decoder, and then enters the ROM. And the control ROM consists of 64 lines. Each of those lines has a given output. More specifically, each of those lines, if it corresponds with an instruction, has a specific output to the processor. And it supports all of the instructions. These instructions are the one for the LC64, but it's required for any instruction to work because it directs the processor.
So for our implementation, we used data flow style. So this could be structural, but because it uses OR gates. NOR. Yeah, scratch that. So because conditional statements really helps with this implementation, so we were able to use assign and just kind of look at the output of the decoder, which would basically end up determining the output of which compare the output of the decoder to the
Instruction.
Yeah, yes, that's the word. So instruction gets compared with the output of the decoder, which then outputs a new output, which basically activates various components. And that'll show up on the next slide, I think.
Doing it data flow is a lot simpler because if you were to do it structurally, you'd have to do all 64 lines when only about 7 or 8 are actually used. So using data flow makes it much shorter and much simpler, and you can just assign the values rather than having to worry about the different gates. It just makes it 10 times easier. This is the test cases.
Barely see that.
Yeah, unfortunately. But
right. That would be inputs.
That's from the decoder. That's a 64-bit number that the decoder.
So when doing test cases, just say, what did you test for? So in this
Okay.
case, we just tested the 7 or 8 different instructions and just made sure the output lines were correct when you got the correct input lines, right?
Yes.
Yeah, that's mainly what you need to say. I mean, we're not going to sit here and read the...
Got it.
Gotcha.
I'm all the way back here.
Just tell us what you tested,
Okay,
why
and
you
then
tested it. Yeah.
we made sure that the outputs were the same as the instructions that it was supposed to be.
Yeah.
Perfect.
So like,
Oops.
Yeah, no, I mean, that's what we tested and we confirmed at the end. Yeah, that's all. That's what's important about the presentation.
We had a few issues. We had to learn the syntax for conditional statements. We had trouble getting them to work. We also needed to learn how to use the assign statement because we hadn't used it before, and we didn't know how to input a whole binary number at once, and so we had to learn the syntax for that. And then the decoder needs to be finished in order for the control ROM to work. So we both had to finish that in order to test it.
Sure.
So control ROM is 7 NOR gates that work in parallel. So so they all have the gate delay of 2, which just and since they're parallel, it's just total gate delay 2. Yeah.
The end.
Thank you, Sam. Any questions? No questions?
Harry.
Oh, there we go. Thank you, Harry.
I'm going to try for everybody.
Good.
Did you have fun doing this?
Yes.
And that's all that matters.
Yeah.
Nice. Well played. Okay. So one thing that would definitely help is a diagram. You said you
Okay.
use NOR gates in order to implement this?
Well, I was researching to look up what the gate delay would be, and we use data flow, but if you were going to do it structurally, it would use the NOR gates, and so that's how I calculated the gate delay.
Okay. Because be interested, I would want to know how you'd set up the NOR gates. The way I showed in class to do this is you put diodes on a wire, and you don't really do that in Verilog, which is why you go with the data flow or behavioral to model what it is.
So what I found is that if you have the control lines coming out, each of them is sending high current down.
Right. Oh.
And
well,
so-
there's one line that's sending high current.
Yeah, there's 64 lines coming out of the decoder. So say
And
one of
one
them
is on.
one of them is activated, and that line is sending multiple lines down to one of 7 NORs. If it hits that NOR, then it's reversed to a 0 and
Okay,
outputted.
so
If it doesn't, it's
Okay.
the 0 becomes a 1 and it's
Sure.
outputted.
So yeah, no, that'll work. But for presentation, a diagram of that would have been very helpful.
Okay.
Okay. But besides that, good job. Any other questions? No. So good job. Good work.